Okay. What did we have to multiply with to rationalize this denominator? Root 6. At the top and at the bottom, because I'm only multiplying with 1 now, and therefore I'm not changing the equation, I'm just manipulating it. And then at the top I have 3 root 6, and at the bottom I have 6. Am I right? And then my answer is going to be root 6 over 2. Who got it right? Good. And then you had to do D. What did I have to multiply with? Root 8. And then my answer is 3. And what will be in the root? It's root 16. Do you all understand that? No? And at the bottom I have 8. And then what is the root of 16? 4. So did you notice I can calculate that? Then it gives me 12 over 8. And that can still be simplified to give me 3 over 2. Who got that one right? Good. Do you all understand it?
What if I skip that the one where you wanted A and that's 16?
You skipped that step, you went to that straight. It's fine. Okay, then number 2, A. What did I have to multiply with to rationalize that denominator?
Times
1 plus, ne? Okay, then my answer will be 2 bracket 1 plus root 3. And at the bottom it will be 1 minus 3. And you all understand why it's 1 minus 3, ne? Everyone? And then my answer is, I'm going to go on here at the bottom. It's going to be 2 plus 2 root 3 over negative 2. Am I done now? No. Did you notice you can take out something in common at the top? You can't cancel when it's 2 terms. You have to take out something in common. I take out the 2, then I have 1 plus root 3 over negative 2. They cancel out, and my answer is negative 1 negative root 3. Who got that one right? Good. Do you all understand? Okay, well, there are still 1 or 2 of you writing. I'm going to start talking to you about today's work. So you remember when we started this year, we started with exponents, but it was exponential expressions. Right? It didn't have an equal to sign. We didn't solve for x. And then we worked with surd expressions. That was what we were busy with yesterday. We finished it yesterday. Now, when you were in grade 8, when we started doing algebra, we started with algebraic expressions. And when we were done with it, we went to algebraic equations. Okay. So an algebraic expression was, for instance, saying 2x plus 3x. Then you simplify it and you got 5x. Algebraic equations is saying 2x plus 3x is equal to 10. Then your calculations were the same. You still say 2x plus 3x is 5x, but then you had it equal to 10 or whatever. And then you divided with 5 on both sides and you found the value of x to be 2. Do you remember that? Okay. So now when we're going to work with algebraic equations, it's going to work in the same way. Our simplification will still be the same as we did it at the beginning of the term. But now after we've done all the simplifications, we'll have it equal to something. And then we can calculate the value of x. Now I'm going to do exercise 7 with you. Not all of them, just a few of them. It's a revision of grade 10 work. Okay, so it's just to remind you what an exponential equation looks like. So you can write a heading. Oh, number 3. I forgot number 3. Askies. Okay, you write the exponential equations. I'm just quickly going to do number 3 afterwards. Sorry. Okay, at number 3, they ask you to prove that it's equal to root x. Let me write it here. Root x bracket y plus 1 over x. Okay. There are different ways that you could have done it. I would start by rationalizing this denominator. Okay, so I multiply, let me use a pencil here. I multiply this one with root x over root x. Because I'm just multiplying with 1, so I'm not changing it. So I've got root x over x plus root x y over x. You see that? Doesn't matter. What's 5 times 2? 10. What's 2 times 5? 10. Okay, we call that the commutative law. With multiplication and addition, it doesn't matter if it's swapped around. Okay, and now when I look at the answer that they want, they've got a common denominator. Now in this case, I don't even have to change it. There is a common denominator. So I put both of them over x, and then I've got root x plus root x y. But then I see at the answer they also took out a root x in common. Is that possible for me? Yes, because both terms have got a root x. So it's root x, then what remains is 1 plus y over x. And then the left side is equal to the right side. Are you all happy with that? Okay. Alright, exponential equations, and then you can write activity 7. It's on page 12. You don't have to open your textbook. You can if you want, but I'm going to do the sums with you here. But I'm not going to do it alone, so you have to give me answers, ne? You help me. Let's start just with an easy intro one. Okay, so these were the type of sums that you got in grade 10. You see exponential, you see the equation. So when we want to solve an exponential equation, we try to get a base and an exponent on the one side and a base and an exponent on the other side, and then we want to get our bases to be the same, and we want to throw them away then, and then we just work with the exponents. Do you remember that? Okay. So if I look at this one, this base is 1 and this one is 3. Is there any way that I can make this one a 3? If I times it with 3, I have to times with 3 on this side as well. So I just have to rewrite it differently. Now this is a very important one that you always have to remember, and that is that anything to the power of 0 is equal to 1. So yes, although it's a 1, I can write it as 3 to the power of 0. If that was a million to the power of x, I can write 1 as a million to the power of 0. Anything to the power of 0 is equal to 1. You all understand that? So now I can write the answer x is equal to 0. You don't have to show that step. Okay, the second step. I'm just showing it to you now so that you understand where I'm getting the answer from. And then we'll do B. Okay, tell me how I can write the square root of 2 as a base and an exponent. Not squared to the power of a half. And now my bases are the same, can you see? So I throw it away. X is equal to a half. See? Now let's pretend this is not an equation. We are in the first week of mathematics, exponential equations, what would the problem have been with 4 to the power of x? It's not prime. What's the secret to mathematics? Stays the same. So how can I rewrite 4? 2 to the power of 2, and then it just gets an x. And can I write 8 as 2 to the power of something as well? 2 to the power of 3. Then my bases are the same, I can throw them away. X is going to be equal to 3 over 2. Do you all understand? These were difficult sums in grade 10, eh? Do you remember? Now it's very easy. Right, let's do D. I want a base and I want an exponent. I don't want a fraction. How can I write 1 over 9? 3 to the power of negative 2. Do you all know how I got to that? 9 is 3 to the power of 2. Then I take it up so I don't have a fraction. Then it's 3 to the power of negative 2x. Can I write 27 as something? And then x is equal to negative 3 over 2. Right, E. Okay, listen to me. The things that we are currently working with, we've got normal number format, which is just a normal number. We've got exponential format, where I've got a base and an exponent. And we've got surd format, where we have a root. I can have 3 different things that all have the same value. But the one is in normal number, the one is in exponential form, and the other one is in surd form. But when I have 2 things that are the same format, we need to work with them. So listen to me. Only a normal number can work with a normal number, or can calculate with a normal number. And only exponential format can calculate with exponential format. And only surd format can calculate with surd format. So for instance, if I look at this 16, this is a normal number. And that one is exponential number. And this one is a normal number. Now because I have 2 normal numbers, I can take the normal number to its friend, the other normal number. Do you understand what I mean? But there is a way I can make this one exponential. I will show you the second method with it. Then I work in exponential format. So there's not just one way. But just remember, you can't, for example, let's say this question was only 16 to the power of x equal to 64. You can't divide this 16 and divide the 16 there, because this is exponential, this is a normal number. Do you understand what I'm saying? Okay, so method 1, I divide with 16 on both sides. Okay, so here this one cancels out. Then I'm left with 16 to the power of x, and on this side I'm left with, what's 64 divided by 16 is 4. Now I can take them, can you see the problem there? They're not prime. I take them to prime base. What is 16? 2 to the power of 4x, and 4 is 2 to the power of 2, and then x is going to be equal to a half. Two divided by 4 is equal to a half. Now let me show you if I use the exponential method. This one I personally think is a bit more difficult, but it's important that you understand what I'm doing here now. Do you see that these two, although the one is in normal number base, or in normal number format, and this one is in exponential format, if I were to give this one its exponent of 1. Can you see that they now have the same base? And I am multiplying. What do I do with bases that multiply? What do I do with the exponents? I plus. So I can write this as 16 to the power of 1 plus x equal to 64. Okay. Now this one I've changed to be exponential. Now I also need to change this one to be exponential and somewhere get it in prime number as well. So 16 I can write as 2 to the power of 4 plus 4x. I multiply the 4 in. And 64 I can write as 2 to the power of 6. Now my bases are the same, I can throw them away. 4 plus 4x equal to 6. The 4 goes over, it subtracts, so I've got 4x equal to 2. So x is once again equal to a half. So they both give us the same answer. Do you all understand that? Remember what I said? You can't decide, I prefer this method, because in a different sum, the preferred method might not be available for that specific sum. So you need to understand all the methods. Okay. So what do you think we're going to do here? I've got a normal number, I've got exponential, I've got a normal number. You what before? Divide, no? Do you agree with me? I divide both sides with 4. Then can I somewhere write a quarter correctly? How will a quarter look? Better than that? Thank you, Barnella. 2 to the power of negative 2. And then on this side, what is 8 divided by 4? 2. And now my bases are somewhere right. Do you all understand what I did there? And now I can throw my bases away. That exponent is 1. Remember, it's not 0, it's 1. So I've got negative 2x plus 2 equal to 1. Okay. Then the plus 2 goes over, it subtracts. Then I've got negative 2x equal to negative 1. And then x is equal to a half. This was a difficult one in grade 10, eh? But now it's not difficult anymore. Okay, first off, I think the fraction might bother you, ne? But hear me out. If I were to multiply with 3 to the power of x on both sides, I would get rid of it here, but then I'd end up having a normal number and exponent next to each other, or exponential number next to each other, which might be a problem. Okay. So what I would do is I would see if I can simplify this. Now, do you see the bases are the same? And I'm dividing. What do I do with exponents when the bases are the same and I divide? subtract. So don't you agree? I can just say 3 to the power of 2x minus 1 minus x equals to 3. And now my bases are the same. I've got base and exponent, so I can throw it away. So I'm going to simplify this. What is 2x minus x? X minus 1 equal to 1. That minus 1 goes over, it becomes plus 1, so x is equals to 2. Easy. Okay. Are you done, Untitled? Okay, now I've got a bit of a problem here. Let me show you why. Maybe some of you felt that we can divide with that too, because I've got exponential, normal number, exponential. So to get rid of that normal number, I can divide with 2 here, it's going to cancel out, and 0 divided by 2 is going to be 0, that's still fine. But then here I'd have x to the power of, 8 to the power of negative x over 2. Then I'd still have exponential of the normal number. Okay, so that doesn't work right now. So what I suggest is let's just get everything in its prime basis and see what we have then. Okay, so 8 is going to be written as 2 to the power of 3, and can I somewhere write it already as 2 to the power of negative 3x? Minus 2 times, how can I rewrite 4? 2 to the power of 2, I'm somewhere going to multiply it in, then it looks like that. So now I have two things that I can do. Either I can move one of these terms to the right hand side, then at least I've got base exponent, normal number, base exponent. I can do that first, that will be fine. Or I need, and this is what I'm talking about now, I have to do in any case, I need to get that one, that's a normal number, in exponential format. Because I'm not going to be able to get rid of it. So in exponential format, it would mean I have a 1. And do you see these two are multiplying? And when I multiply, what do I do with the exponents? I add them. So I can rewrite this thing as 2 to the power of negative 3x minus 2 to the power of 2x minus 2 plus 1. I want to take a minute so you all understand what I did there. Do you understand? Must I go through the steps just once more? Okay. I changed the 8 to prime. The 2 was prime already. I changed the 4 to prime. Now I still had that normal number. I can't divide it. Okay? I can, but that's going to be more difficult in the end. So what I can do is I make it exponential because I see when I give it an exponent, I've got bases that are all the same. And when the bases are the same, I can apply the exponential rules. And the exponential rules say when I multiply, I can just add the exponents. Okay? So I've made that term that consisted out of two things, I made it 1. Okay? Because remember, what we want to get at is a base with exponent and a base with exponent. So that one has been the problem. Do you all understand? Okay? Then I added it. Now I'm just going to take it over. I'm just adding that 1 to the negative 2, okay? And it's now on the other side and it became positive. And do you see now my bases are the same? I can throw them away. I have negative 3x equal to 2x minus 1, and then I've got 5x equal to 1, and then I've got x equal to a fifth. Okay. Let me give you a challenge. There are 6 of them being added. Okay, so I did this one with the Afrikaans class, the one Afrikaans class yesterday as well. And they all said it's very easy, ma'am. On the left hand side, it's going to be 6 to the power of 6x equal to 6 to the power of 6x. My bases are the same. X is going to be equal to a real number. It can be anything. Is there anyone who agrees with them? You are wrong if you agree with them, but just tell me, did you also feel like you wanted to say it's 6 to the power of 6x? Okay, because that's what they want you to do. That's the trick. Now, I want you to remember that what you just did is you added the exponents. Okay? But the calculation is addition. So you can't add exponents. When do we add exponents? When it's times. So this is not a multiplication sum. Now I want to change the sum and just ask you a question. If it was x plus x plus x plus x plus x plus x equal to 6 to the power of 6x. What is x plus x plus x plus x plus x plus x? 6x. Okay? Now we have a method, we call it the K method, where I substitute any variable inside of a gogga. Now this thing is a gogga at this stage, a gogga that repeats. So if I were to write this as k plus k plus k plus k plus k plus k, do you all agree we'd end up with 6k? Okay? Now, what the K method does is it makes the actual mathematical calculation easier without the gogga confusing you. Okay. So now I've done the calculation. Now I go and substitute the gogga back into K. And then see what it's going to look like. 6 times 6 to the power of x equal to 6 to the power of 6x. Does that make sense? I had 6 x's. Sure. Okay. So what happens when I add them? I have 6 x's. Are you all with me? All right. Now I have kind of the same situation as I had at m. Because I can't get rid of the 6. I can't divide with the 6 because this is an exponential number. This is a normal number. This is exponential. Normal numbers can only divide with normal numbers. Exponential can't divide with normal. But do you see I can make this one exponential? I can just give it a 1. And I'm multiplying. What do I do with exponents when I multiply? So I've got 6 to the power of x plus 1 equal to 6 to the power of 6x. My bases are the same. I've got base exponent, throw them away. X plus 1 is equal to 6x. 5x is equal to 1. X is equal to a fifth. Do you all understand that? So this is a trick question. Okay. It is one that has to make you think. Last time. Okay. I cannot add these exponents because it's addition. I only add exponents when it's multiplication. So I see that I have 6 terms that are all the same. So if I have x plus x plus x plus x like that, 6 x's being added, I would say it's 6x. If I catch a fish and another 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 fish, I have 6 fish. Okay, this is my fish. I caught one. I caught another one. I caught another one. Another one. Another one. Another one. So what do I have? 6 fish. But this is a goga fish. Okay? That fish is named a 6x fish. So I've got 6 6x fish. Does that make sense? Karanelu? Okay? Now I have a normal number, exponential normal number. I need to get them in the same format, because otherwise I can't get rid of the normal number. So what I do is I just give it an exponent of 1, because I see then my bases will be the same, and it's multiplication, and when I multiply I can add the exponents. So I added the exponents, my bases are the same, I threw it away. So normal simplification. Are you all good with that? Okay. Now we can get to grade 11 equations. So you can write example 1. Okay, grade 11s. Please tell me that this sum, as it is here, looks familiar. Because we did this type of sum with expressions. Do you remember it? They gave you a left-hand side and then we said, prove it equal to the other side. Let me tell you where we did it. It was right around the beginning. Exercise 2, yeah, here it was. Example 2, when we started with exponents. Here we did it. We had 2 to the power of x plus 3 times 2 to the power of x equal to 5 times 2 to the power of x, and we asked you to prove that the left side is equal to the right hand side. Let's quickly recap what we did. We gave each one its own base when necessary. Then we said there are 2 terms. I take one, what they have in common out. What's left I calculate, and then I saw the left side equal to the right side. Okay, this is exactly the same question. This is also still an expression. So we just want to prove that this is equal to this. So first off, what did I say? We give each one its own base. Now because there are two terms, I need to take out something in common. What can I take out in common? 2 to the power of x, then I'm left with 5 plus 3 times, can I somewhere calculate 2 to the power of 2? What is it? 4. What is 2 times 4? 2 times 4. Hi, Bo. Am I saying 2 times 4? Yes. Sorry. What is 3 times 4? 12. And 12 plus 5? 17. And can you see the left side is now equal to the right side? Okay, so I've proven it. Alright, now did you notice that in this example, this is question A. Now I've got question B. And I want you to write down the words as well. Hence, do you know what hence means? Hence, solve for x if 5 times 2 to the power of x plus 3 times 2 to the power of x plus 2 is equal to 68. Do you know how to use the hence in mathematics? Because when I see your papers, you don't know how to use the hence. Okay. So hence means you've done the job at number 1 or at A. Use your answer in number A to solve this sum. So instead of taking this whole thing again and going to simplify it again, you've already done the simplification. This thing is 2 to the power of x times 17. And then you let that be equal to 68. Do you understand how hence works? So you don't go and do the job over again. You've done it. And even if it was a question where you struggled with it, you weren't able to get it to that, then you still use the answer that they gave you. Don't go and use your wrong answer. Your sum is not going to work out. You use the answer that they've told you what it is. Okay. I've got exponential, I've got normal number, I've got normal number. Because I have two normal numbers, I can get rid of this normal number. Do you agree with me? How? Divide. Okay, so on the left hand side I'll have 2 to the power of x. And what is 68 divided by 17? 4. How can I rewrite 4? 2 to the power of 2. And then x is equal to 2. Done. Is it difficult? Do you see it's the same as what we've been doing? I now just get an actual answer and I can solve for x. Can we do another example? Are you all done? Done. Okay, example 2. Now we're going to take it up a notch. No, not really, not yet. Almost. Okay, so can you see they're not asking you to prove the left side to the right hand side. They want you to solve for x. Okay. Now let's pretend the right hand side was not there because there's nothing to do on the right hand side. Do you agree with that? But there is something to do at the left hand side because I see a 9. And do you know what's the problem with 9? It's not prime. We are poets. 3 to the power of 2x plus 3 to the power of 2x plus 1 and I sommer give it its own base. What can I do now? I can take out something in common. Do you see, Vanelle? Do you all see that? I take out 3 to the power of 2x and then I'm left with 1 plus 3. What's 1 plus 3? 4. Okay, let's just quickly take a look at what I have here. I have a normal number, exponential number, normal number, surd. Let me ask you this first. Can I get rid of the normal number? Yes, I can, because I've got a normal number on this side, I've got a normal number on that side, so I can just divide with 4 on both sides. Alright, you can see what I'll be left with, né? 3 to the power of 2x and the square root of 3. So the one is exponential, the one is surd. What should I do? Here I'll have 3 to the power of 2x. Here I'm going to have square root 3. So the one is exponential, the one is surd. I cannot work when things are in different formats. Tiamu? Thank you. I need to get them in the same format. Always. And remember what I wanted. I want a base and an exponent. I want a base and an exponent. I don't want a root. Okay. Are they the same? Yes, I can throw them away. So I've got 2x equal to a half. And now I divide with 2. Do you know what a half divided by 2 is? I've got a half a chocolate. I divide it between 2 of you and you say each one of you are going to get one whole chocolate. Magic. Ha. It's a quarter. Okay. Don't make the mistakes with the fractions. Okay. Do you all understand that? Okay, let's try another one. Okay, are you ready for this one? Are you sure? You've got lion hearts, ne? We can do it. Okay, this sum has got something different happening in there. I'm going to tell you that from the beginning. And then I'm going to show you all the options that I know that are running through your heads now. Your first option, maybe someone thought they saw the 27 and they thought they can write it as 3 to the power of 3. Is there someone that saw that? No one. You saw that. Okay, so it might be that I've got 3 to the power of 2x plus 6 times 3 to the power of x minus 3 to the power of 3 equal to 0. Okay? Then maybe some of you thought, let me take that one to the other side. Then it looks like that. Okay, then I've got my exponentials on one side, I've got the normal number on the other side. Now maybe some of you thought, let me take out something in common. Then I'll have 3 to the power of x bracket 3 to the power of x plus 6 equal to 3 to the power of 3. And then I'm stuck. Because if I divide this 3 to the power of x, I'll have normal number and exponential together. If I divide with this thing, there's still exponential and normal number together. There really is nothing that I can do at this stage. Do you all understand that? Do you see that the plan is not working? Would you be able to do that sum? Which factors of 27 will give me 6? 9 and 3. 9 minus 3 will give me 6. Can you all see that? Okay. Now there is the secret to this one. We can also use the K method. Let me put in a K so it's not confusing. I can't make this term K because this term doesn't repeat. Can you see that? But I can make this term K because this term repeats there. Listen to what I'm saying. This is the square of that. Because if I've got 3 to the power of x times 3 to the power of x, do you see it's being squared? There? What will I do with those exponents? And it will give me 3 to the power of 2x. So this is something that you need to remember, ne? If this exponent is double that one, ne? Then it's this one square. So if I make that one k, this one can be k squared. Okay. Now I can factorize that. I'm going to do it using the k method. So it's going to be k and k. You said 9 and 3, ne? Plus 9 minus 3 or minus 9 plus 3? And then k is equal to negative 9 and k is equals to 3. I've done all the mathematics I can do, ne? Now I need to put the gogga back in. What was the gogga? 3 to the power of x, not 3 to the power of 2x. It was 3 to the power of x equal to negative 9 and 3 to the power of x equal to 3. Now let's see how smart you are. I haven't solved for x yet. Okay, I've only done the simplification. Can I write negative 9 as 3 to the power of something? No. Thank you so much. That it's a definite no. Negative 3 and 3 is not the same thing. If you have R1,000,000 and I have negative R1,000,000, I need R1,000,000 to have nothing. You already have R1,000,000 more than nothing. So there's a big difference between negative 3 and 3. So there's no way that I can solve this one. So I know this option is not working. But this one, what's 3's exponent? 1. So I know x is equal to 1. Okay. That's how you would do the sum using the K method. Do you see the maths in it? Was not difficult. It's normal factorization. So many learners, they don't even like the K method. They've taught themselves and memorized that if this exponent is double that exponent, and there are 1, 2, 3 terms, that this is a quadratic trinomial. Does this make sense to you all? What do I do with a quadratic trinomial? I factorize it, hockey, hockey. So they say, they know, if you look even at this K method, when you make your two brackets, it's this one that comes first, not the square one, eh? Because it's this one's square root, it's 3 to the power of x, 3 to the power of x. And that's literally the only thing that you do differently. You just take the first term square root. And then you go and look at 27. I look for factors of 27 that will give me 6. It's 9 and 3. It's plus 9 minus 3. So I've got 3 to the power of x equal to negative 9. That can't work. And I've got 3 to the power of x equal to 3. Yes, x is equal to 1. The learners prefer this method. It's your choice which one you prefer. There's the K method. there's the method, just a normal one without using K method. Is it? Still, we are going to finish by the end of the week maybe, or Monday. Okay. Alright. What you're going to do for me for homework is going to be sums. I'm only going to give you one that's like this third example, okay? And I will tell you which one it is. But the others is taking out something in common. So just open your textbooks on page 13. It's activity 8. I want you to do number 1, the first column, and then just look at E. I think in most of your textbooks it will have been changed. It's 3 to the power of 2x minus, it's supposed to be minus, not plus, 2 times 3 to the power of x plus 2 plus 81. And that is one like example 3. Okay, you can give it a star. And then in column 2, you can do B, D, and F. And F is also one like example 3. Okay, so E and F, they're example. Wait. Let me change it. I don't want to give you too many of them. Leave out G. Okay, so let me read to you which ones you have to do. A, C, E, F, and I. A, C, E, F, and I. Please remember, look at me. Look at me. All of you. If the exponent repeats, it looks exactly the same, then you take it out in common. If the exponent, the one exponent, is double the other exponent, it's a quadratic trinomial. Do you understand me? Okay, so those are the ones I want you to do for tomorrow. So it's A, C, E, F, and I. Right. And you all got it that E is negative in front of that term, eh? Okay. Like that. Kanyasile, if it's too light, you can come and take the picture here as well.